So good afternoon, everyone. We are now in the session of nature conservation, decarbonization, and robotics. I see a couple of speakers so far. Let's wait 1 more minute to see if the other speaker will join as well. In the meantime, let me introduce myself. I'm Marcello Calisti. I'm associate professor at Scuola Superiore Sant'Anna. I work mostly on field robotics, and I do bio-inspired robotics for monitoring the seaside, the seabed, and also I work in the past in agricultural robotics, again with the focus on climate, sustainability, and now we can use robots to help our world. With me this afternoon, there is Professor Marco Frey. I see him there. Will O'Brien, right, from Ulysses, and Chris Heckman. I think that Guillaume Charron is going to join soon as well, I hope. But in the meantime, let's start our session with what we are going to do. I'm your moderator, so basically I will just ask you some questions. Guillaume is here as well. So I'm your moderator, so basically I will ask some questions to all of you. Then I will collect the questions from the audience, the people that are attending the summit, and I will pose them to you to start the discussion. Then we will reflect at the end of the session on what is the hot take from your speech, and then we will close our session and we move on to the next one on funding climate robotics. But let's start with a little bit introduction from your side. Who are you? What are you doing related to the specific challenges you are tackling? Why is that important? And how are you doing that? Starting with Professor Marco Frey.
Thank you very much. I'm a professor of economics and management, so not robotics, but I coordinate an interdisciplinary center on climate and sustainability. So my work in the last 3 years, I work in the field of sustainability since more than 40 years, so too much. When in my discipline, nobody's, or very few people considered environment and sustainability as a specific field of study. In the last 3 years, I coordinated this new adventure, putting together different perspectives. So we work in the field of decarbonization, considering the policy perspective, the technological perspective. For example, twin transition, considering all kind of solution, but also policy instruments to support the use and the diffusion of renewables, or for example, solution for energy efficiency. The same in the field of ecosystem services. This morning we had a meeting for an European project regarding a nature-based solution in the Mediterranean Sea. And in this field is also important and increasing the importance of robotics in different fields. So in a traditional field about solution in manufacturing, for efficiency and for decarbonization. The second level is how we can obtain information about ecosystems, for example, or another one, it's about the interaction with humans, but also with nature. So we had some example of cooperation with colleagues, Marcello is one of them, about this kind of integration of competencies.
Thank you, Marco. I have the unfair job of keeping the time as well, so I have to interrupt you. Sorry about that. I know that you can present for a lot of things, a lot of amazing things, and we saw that also in the other panel about agriculture. The theme of climate robotics is not only about robotics; it's about the whole ecosystem. So it's about policies, it's about skills, it's about interaction, adoption, so a lot of elements. So thank you very much for joining the panel. I will move to the next speaker. Why the challenge that you are tackling is important, what are you doing, and how are you doing it? Please introduce yourself, Will.
Thank you very much, Marcello. Hey, hello everyone. Good to be here with you today. My name is Will O'Brien, and I'm one of the founders of Ulysses. We are building a general purpose robotics platform for the ocean. So today it still remains extremely difficult to do the most simple of tasks in the ocean. The ocean is not an easy place to do anything, let alone something as difficult as building an autonomous robot. And we see all of these companies trying to build general purpose robots on land. We have people trying to build humanoids and these sorts of things, but these form factors will not continue into deep water. So what we're building is what can be termed as a marsupial or dual domain robotic platform. So we built an autonomous surface vehicle that launches and releases autonomous underwater vehicles. These underwater vehicles can be attached, sensors attached to them, or robotic implements attached to them to execute various tasks. And we built these two kind of platforms and integrated them in a very unique way that's never been done before, the launch and recovery system. And we've also done it about 1/10 of the cost of anyone's ever built either of these vehicles for widespread use in the ocean. So the first domain that we've focused on automating has been the world of seagrass ecosystem restoration. So I'm not sure if everyone here is familiar with it, so I'll explain. So seagrass, or Posidonia, as you might know it in Italy and other parts of the Mediterranean, is a critical ocean ecosystem that supports, that draws down 35 times more carbon per unit area than rainforest. It supports about 20% of the fish life in the ocean. It is 10 times more abundant than coral reefs, but yes, nobody's ever really heard of it. It's the ugly duckling of the ocean. And doing ecosystem restoration for this for seagrass is a very time intensive and expensive process. It costs about 700,000 euros or US dollars per hectare to do restoration, and this prohibits projects. So we're losing about 7% of seagrass ecosystems every year, and we're not replacing 7%. We're replacing less than 0.1%. So if this continues, then you have 20% of the carbon in the ocean being released from the seabed. You have 20% of the world's fish stocks, falling away, and it's a very, very bad scenario. So we are building the robotics to automate this solution. We have projects currently in Western Australia with the government there, in Florida with the state government there, and also we're working on the largest seagrass restoration project in the world, one of the largest blue carbon projects in the world in Virginia on the east coast of the United States. Yeah, very excited to talk to you here today about that.
Thank you very much, Will. Restoration is absolutely pivotal to support the health of our oceans, and then, of course, that leads to a healthy planet as well. So, Chris, what are you doing? Why is the problem important, and how are you doing it?
Thanks. And yeah, so my name is Chris Heckman. I'm an associate professor at University of Colorado at Boulder in robotics. And so the work that my group has been focusing on for the past 4 or 5 years has been on degraded rangeland restoration, which has to do, I don't know, I was going to share a little image, but I saw that sharing isn't really working. So it's basically taking an environment from what pretty much looks like a desert with small shrubs that are all dead, or maybe like little patches of vegetation. So what would have been the case if humans didn't sort of affect it through off-road vehicle use or overgrazing? And that generally looks like kind of an area that has far more vegetation on it. And there are, in fact, one of the most interesting parts of this project that we've been focusing on has been the lack of understanding even that the ecological partners have in terms of the level of challenge that the environment is facing, both from anthropogenic factors, but also just climate factors. Drylands are getting worse in the United States, largely stemming from some of the worst droughts we've ever seen, not just in the US, but across the globe, obviously, due to climate change. And as a result, the types of even plant species that can be able to germinate in these environments is changing over time. And so at the one hand, we're trying to figure out how we can intervene through using things like seeding guns and being able to deploy autonomous ground vehicles into large degraded rangelands. But on the other hand, we're also trying to do environmental monitoring to understand what it is that is actually changing in these environments over large swaths of relatively unpopulated areas. The sites that we've been focusing on have been in the Colorado Plateau, which is actually sort of quite ironically named. It's actually mostly in Utah, and it actually can support quite a bit of vegetation with the amount of water that's there, but just we are not seeing the sort of like ability to regerminate like we have seen in previous years. So my team goes out with these autonomous vehicles and does that data collection as well as testing intervention strategies. That's one of multiple projects, but I think that's kind of one to highlight.
Chris, thank you very much. So data collection, understanding the problem, restoring the situation. So there are two both equally important steps that needs to be done ideally together. So that's great. Guillaume, sorry if I pronounced that bad or good. You can instruct us on how to do it properly. Why your problem is important, what are you doing, and how are you doing it?
Yes, hi everyone. My name is Guillaume Charron, so from the French part of Canada, in Quebec. Yeah, glad to be here. I'm a co-founder of Outreach Robotics, which is a quite small company that are working developing robotic tools for field scientists. So what we've been doing in the past 5 years now is developing customized tool to empower the field scientists in doing their actual jobs. We found out so much biologists that are constrained with their actual tool and what they can actually do to conserve the environment. So we've been hearing what they are saying. We've been partnering with them to develop new tools. So to name a few of the projects we've achieved in the past years, the first one that we are renowned for is the leaf sampling tool. So it's a robotic arm that is able to collect leaf samples from top of trees. So it's used in around 50 universities across the world to do surveys on natural forests, and by flying over the forest, we're able to reach and sample trees just like a blood test you would take, but with drones. So instead of using shotguns or instead of collecting like under canopy leaves, we're able to reach the actual samples that people are looking for. After that, we've been also developing the Mamba tool, which is able to collect endemic plant on cliffs. So we've been working a lot with Hawaii Islands and to be able to reach out those cliff ecosystems. And because they've been doing a lot of surveys with drones, now it's what's the next step? You know, those plants are there, they're producing seeds, a few individual left. So now we want to collect the seeds from them, bring them back to nurseries, then propagate them. So like to close the circle of conservation. So we've been handing those Mamba robots that hangs under the drones to be able to actually collect physical samples from cliff surfaces. And then lately we've been also involved in the X-Prize rainforest, where we've used the robots, especially drones, to deploy sensor stations on top of trees. So to do long-term monitoring, you know, drones are able to fly maybe like 30 minutes, 1 hour at max. So it's a short period to be able to actually gather data from environments. So we took another route where we deploy sensors that are meant to stay there for a week, a month long, collect data, and then go get them back with the drone. So we're able to cover like very large surfaces of tropical forest. So those are all glimpses of what we've been doing for field robotics in the last years. So I'll be glad to maybe give some inputs on that during the panelist.
Thank you very much. I think that we saw very nice conservation technologies and that help also the decarbonization. It's always puzzling me what it starts first, the policy or the tool, in the sense that sometimes we have some nice technology, we bring it to the field, and then for some reason there is some policy that does not allow us to do the things in the way that we would like, or the other way around. Sometimes we have policies that promotes us to create new tools. So what is your point of view, Marco? Where should we start first, from the policy or the technology? I think you're on mute.
Yes. I think that you have to work in both directions, but mainly I think it's important to define pathways. So policies could be the first step, but it's necessary to have knowledge about the possibilities. So the capacity to create example of solution for policymaker could be very important. For example, when we speak about BAT, best available techniques, the European Commission, for example, created a place in Sevilla in which it's possible to create very frequent meetings between the expert in technologies, also in companies, and the policymaker. So I think that the capacity to find the connection point in the two dimension could be very important.
Thank you very much. Will, what is one of the biggest challenge on doing a restoration underwater? You were mentioning that part is the technology, and of course, part is also to understanding that your restoration is effective, right?
Yeah, honestly, like one of the most irritating problems we have right now is like the problem of green tape. So like not red tape, but green tape, like the difficulty in getting permits to do restoration, right? Like we have technology that works, right? And we've tested it and it works. But like there's a project I know in like one location in the world where the local people want us to work. We can do like maybe the largest seagrass restoration project ever, and the government won't let us do it. It's like, and it's crazy, right? It's because basically all of our permitting structures are set up for extractive industries rather than regenerative industries. So normally, you know, they want to look after the seabed because they don't want fishermen coming in and they don't want oil and gas coming in, and all of the permitting structures make it difficult to do an activity on the seabed. But now in a world where we need to let people do good things and people actually want to do good things and financial incentives are actually there for people to do like regenerative activities, we need like new permitting structures and new like regulations to enable this. You know, the European Union is really going to have to deal with this problem in the next few years. We've just enacted in Europe the European the nature restoration law, which mandates that 30% of degraded ecosystems be restored by 2030, and all degraded ecosystems by 2050. So this is like a, you know, like an activity like at the scale of like agriculture. But you know, it's like as if we put a ban on agriculture. You know, like it's very difficult to get the permits. So even in many countries in Europe. So I think this is you know, so much of these questions in climate, biodiversity are actually just like not even technological problems anymore. They're just like bureaucracy and regulatory like red tape getting in the way.
Yes. Thank you very much, Phil. It's exactly what Marco said. It's there is something that is possible, no? It's plausible. We can
Mm.
restore, we can do things, and this comes from the technological point of view, and then from the regulations, laws, permits, very, very practical things, policy things that allows or don't allow you to actually put into use your machine. So, Chris, what is your point of view on that? What is your biggest technological challenge, but also some practical challenge related to this aspect? You were mentioning that the Colorado Plateau is in Utah. Is it helping or not helping? How is it working?
Yeah, that's funny. So, well, the environments that we deploy in are certainly very remote. So that means that, and for the most part, when one is deploying robotic systems, it's very convenient if there's something like a soldering workshop or charging stations or anything like this around. But if you don't have access to the internet, for instance, then things get quite tough. That being said, that's not a problem that we don't know how to solve. Some of the largest scientific challenges that result in like technical limitations, I would say today, are things related to high accuracy localization. The types of measurements, for instance, that we're taking are extremely precise. We're trying to get down to sub-centimeter accuracy on whether or not a particular plant has been growing properly, and we need to go back there in an episodic fashion to be able to correlate measurements. And without being able to do that, then you're very limited in what it means to do these types of precise data collections. And meanwhile, if you decide that you want to intervene and test different intervention strategies, the problem actually is the same, right? It's not just a monitoring task, but being able to observe and episodically whether or not vegetation is recruiting. That's a challenge that's is the exact same as if you had the intervention or not. And so in an A/B testing strategy, you need to be able to do matched pairs, and you can't do that unless you can do that relocalization properly. Meanwhile, like I would have showed some photos, but anyone can look up, what the Canyonlands Research Center sort of looks like. It's the site that we generally work in with our partners at the Nature Conservancy. These sites are quite visually austere, and LiDAR localization doesn't really work. And that means that you're kind of relying on GPS, and sub-centimeter accuracy on GPS isn't always available. And so these are just some of the challenges here. But that all being said, there's also some technical limitations related to the engineering of the platform. And so we generally use unmanned ground vehicles like Huskies. We are fairly proficient at outfitting them for various tasks, including the ones that I'm describing here. But the limitations associated with like putting a little actuator at the end to be able to operate around shrubs and be able to do a planting requires quite an engineering task, right? And so all these things result in what is typically a fairly large lift to be able to get us to the place where we can even test an intervention strategy. Those are just a selection of topics. I could go into more, but I think that I've covered at least a few of the hot topics, in my opinion.
Yes, thank you very much. You're right. We struggle sometimes with, let's say, platforms that are commercially available, but we have to put ad hoc systems on them in any case. So there is always a fine balance between making new things and using something that potentially is more robust, but it is not adaptable to.
Yeah, just to be clear, like many of the things that we're talking about, probably Will has the same feeling. Is like, you can go to COTS and you can probably get you 80% of the way with, moderate loss of capability that you were hoping for. Some P1, P2 requirements, but to get to 99% of your P0 requirements with COTS, you're basically out of luck. I think all of us end up in the platform engineering world at some point.
Yes. Guillaume, what are your biggest technological challenge to make basically your dream come true, and what are the difficulties that are not technical that you are facing?
Well, I would say that we've had an approach of trying to make the things the most simple possible, because we have in mind that we won't be the final user of what we want to deploy. Like if you want to have a large scale impact, I think it's worth like having the actual field botanist and biologists out there be able to use your technology, because I won't be able to sample all those plants around. I won't be like, I have a limited capability of like being able to use those robots all around. So you have two options. Either you have, it's easy to use and you have users that are able to use it by themselves with minimal training, or you do fully autonomous technologies. Second option is not a good option, I would say. Going like with the full autonomy is, I think, the worst, I would say, a trap as an engineer. Trying to build those things to do like everything autonomously. As maybe Chris said, like you can maybe reach 80% of the job you can do by doing things a little bit more simple. So everything we've done is kind of assisted to the pilot. So we try to do things that are not requiring too much precision, or are able to like have some margins of error for the pilot. So that's the biggest challenge, is trying to find like what degree of assistance is required for a field botanist to be trained on that system and use it by himself. So I think that's one of the challenge. And also the other one is actually trying to translate what the botanist needs into like engineering requirements. So that's sometimes challenging. And one example I have for this is a person told us like, hey, I need to sample like big branches from the trees. And we are asking like, why those sizes of branch? And it says, because if it's too small, normally it doesn't fall to the ground. So we say, okay, but what exactly are you collecting on those branches? And say, oh, I need 3 or 4 leaves. So you see, like, if you keep asking questions, sometimes then you can find workarounds that has been always done like that. So I think it's all about communication, trying to understand requirement and not aim for fully autonomous systems, at least at first. Maybe in the future years, yes, but trying to find compromise in that way.
Okay, thank you very much, Guillaume. Very, very interesting point of view. Communication as well. Again, as we said at the beginning, sustainability, decarbonization, using robots in this very complex environment is in general a multidisciplinary effort. So it is not just a technical things, and communication is vital under this perspective. And also another point that it's kind of vital, and I'm going to do the other way around this time. So Guillaume, will take again you, and then we will close with Marco. We have 10 minutes left. So just to make a twist, give a twist to the panel. What about economical support? So decarbonization, nature conservation is usually quite, let's say, demanding in terms of cost, but we have 2 company founder here. What is your main, let's say, drive? How can you sell it in a way that you can do good and also be sustainable under the economical point of view?
Yeah, that's a good one. I would say that a lot of people are ready to pay for the product, the working product, but not much people are ready to pay for the development. So it's kind of being always in the middle. And to have something that has a breakthrough, you need to go some development phase. It'll take time, testing. So a lot of people approaches us and say, hey, I would be ready to like pay for the value of like the actual final product, but not for all the path that goes there. So you need to always find like pre-money to do the development. A lot of it goes through funding from government, also like partnering with a big player that has a money to invest like from the beginning, or something that might also like, there's always risk into a technological development. So that is willing to take the risk with you. So I would say that's the highest difficulty, is trying to find the early money to do the development, even if you know there will be like many users that will want that final product, it does not mean that all those people are willing to pay for the development. So, and that's always balancing also like the price of the final solution. If it has to absorb all the development before, sometimes it seems too expensive for the final user. But if you take into account all the years that has been spent into it, then it makes sense. So that's my perspective on those like new solutions that comes out, and it's not always easy, I would say, to be able to do like the full development and to find like the money for it.
Chris, what do you think about this element that Guillaume just said? And we potentially, if we have a robot or a solution that is perfect, everyone will use it, but we are not there. We are on the prototyping phases. How to bridge this?
Absolutely, yeah. I mean, I think that this is not a problem specifically for climate robotics in particular, but really robotics at large, right? We don't have platforms that are at the place where we can acquire them and easily swap them out and with different types of end effectors or sensors to solve different types of problems that then result in more robots solving lots of tasks. And I think that climate robotics, as intriguing as and exigent as this problem is, it's suffering from the same challenges. And unfortunately, when we look at the places where robotics, especially autonomous robots, but robotics in general, is able to really make a huge push, move the needle a little bit when it comes to being able to performantly handle their tasks. It tends to be in places where humans literally can't do it. When we think about things like going to Mars or something like this, where it's sort of repetitive, so autonomy is not really needed. Like you think robot arms in factories, or places where there's an enormous cost imperative, because it requires such an enormous amount of engineering to pull it off today. So self-driving cars, maybe home robots and other things of this nature, right? And that's where we're seeing that's where robots actually work. The rest of them, it's well, how are we going to make it work in this climate context? Hopefully we can build some good tools. To Guillaume's point, it's autonomy is not always going to be required, right? We could actually use humans to be able to observe, in most cases, or in any case besides the most benign. I think about my problem specifically when it comes to rangeland restoration. There's a lot of things that if we can build a tool that's able to go and repeatedly do this sort of intervention task or measuring task, then that is actually something that probably for the most part we can pull it off 99% of the time, and then have the human help out the other 1%, and we need to work out that interface. But that's sort of where all autonomous robots sit today. There, I shouldn't say all, but many cases. I'm sure, having worked with a little bit with gliders and autonomous surface vehicles before too, it's we may not need to. Maybe we can build an autonomous robot for some tasks like that, and I know that there have been successful deployments in cases like that too. So I don't mean to cast with too broad a brush, but I think that a lot of these kinds of problems are still, we don't really have that tooling to say yeah, we can solve these problems universally.
Yeah, that's great, Chris. Thank you. And you mentioned autonomous cars. No, Will, I think one of the biggest driver and push for development in autonomous driving has been the DARPA Robotic Challenge, the first one, when they have to do the autonomous driving. What do you think about this problem? Can some actions, some initiative on prizes, on award or competition potentially help bridging this element?
Yeah, I mean, absolutely. I think if you look at in the world of ocean, yeah, you mentioned the DARPA thing for doing things on land. I mean, similar incentives are pulling investment into autonomous vehicles in the ocean. One of the hottest defense startups right now is a company called Charron. We're building autonomous surface vehicles. They founded 2 or 3 years ago. They're a unicorn now. And they're building autonomous surface vehicles for the ocean. So and that was primarily spurred by a US government decision called the Replicator Initiative, which they set up about a year ago, which is to buy large quantities of autonomous vehicles or drones for military use cases. So I think we see this as well, like even like in carbon removal, Stripe and others started the Frontier advanced market commitment, where they pledged to spend $1 billion on carbon removal if you could supply it and meet these criteria. So I mean, interestingly enough, like for us to achieve like the kind of radically low price points as well, like we're downstream of basically everything that's going on in self-driving cars and aerial drones, right? Like we're using the same motors that they're using in like a lot of drones. We're using EV battery cells instead of custom batteries for our vehicles. So we're actually like leveraging these like
I think that will the connection is about this is okay, because we have 3 minutes left, and I think that Marco can wrap it up to us with maybe one question that is very relevant for all of us. Is sustainability paying? Is conservation, decarbonization paying off?
Yes.
If it's too challenging, just tell me.
Yes. It's a very important question also in European policies in the next month. So sustainability pays in general. When you decided to create a long-term pathway, strategic pathway, as a company, as a research center, and in this case, you can find the evidence of the capacity to be more competitive. This is for state, this is for companies. I'm the chair of UN Global Compact Italy, with more than 700 companies involved. And we did a work together in the last month about the connection between sustainability and digital transition. And the position of the participant, mainly big companies, it was if we work with strong attention on development, investment, with the participation also of institutions, but mainly driving our choices in strategic term, we can achieve the strong connection between sustainability and competitiveness. We have some fields in which this is not so easy. For example, in the oceans, challenges, and biodiversity challenges. It's more simple in circularity, in efficiency, related solutions, but it's a question of time. We need the support to manage the time, especially if we are startups or researchers at the beginning of the process, but we can do.
Amazing, thank you. We can close it with these beautiful words of hope. So we can do it in time, going all together in the same direction. I'm wrapping up the session to allow people prepare for the next one, which incidentally is funding climate robotics. So that's still a very relevant topic. I thank again all the speakers. We got great insights going from how we have to co-design our solutions, how companies are already doing great technologies, how we are on the verge of new developments, how we can do that, and how companies seems ready to understand, maybe not at all the scales, but still it's a process, as Marco said, of time and passion and believing on the path and on the road. Thank you all again. I hope we will stay for the last part of the summit, and see you soon. Bye.